Okay, so this is actually for week 5 Tuesday. It's a study guide for quarter 4, and this is actually page 1. Read the question, please.
Um, Find the most important function.
Hey, remember the functions, you have linear. What else?
Um,
There's linear. Linear, remember, is a constant, right? It's either add a number or subtract a number, right? A linear exponential. And there's one more. I can't remember what the other one was. So. Exponential is with exponents, right? The numbers go from small to very, very big very quickly. What was the one if you multiply by something? I forgot. That's great. My computer just froze. So take a look at A. How are you getting from, you see how X is 1, 2, 3, 4? But then where Y, you have a -2 to 2. How do you get there? From 2 to 4, how do you get there? Okay, well, I don't know the hell's wrong with my computer, but
I think it's working now.
linear exponential, what's the next one?
Um, Linear exponential. I don't know.
Exponential. So this one is when you have like a number, like a cube, right? Right? And then what are the different types? I don't go grab go ask AI. Type it in. Is it geometric and I don't know this one. Linear, exponential, quadratic, that's right, quadratic. Quadratic, I remember now. I think the first one it was like or is not constant and it's even or odd, remember? And then quadratic. Remember this one is you have two types of patterns, right? It's inconsistent. That's the first one. And the second pattern is consistent. Remember that? All right, so let's go over this one. How are you getting from -2 to +2? What do you do?
Um, Multiply them both.
Really? What are you multiplying -2 to get a +2 for?
And
Add what? What are you adding?
-2 and +2.
No, I'm saying -2. How are you getting from -2 to +2? Are you multiplying a number? Are you adding a number? How are you getting there? How do you get from -2 to +2? What do you add? -2 plus what equals 2? What about 2 to 6? What do you add? This week, you're going to be watching a lot of videos on this. You understand? This is consistent. You're just adding 4. So therefore, it is linear. Should not be forgetting this, dude. Do the same thing with B. Okay, so the first one that you have here was 1 and what? For question 2, 1 and 3?
Yes.
And then 2 and 9?
Yes.
And then 3 and what?
7.
Next one. Is
1, 12.
that it?
Mhm.
That's not linear because you're not adding or subtracting. I think it might be quadratic.
Can you go back to the answers? I didn't finish yet. Please.
Yeah, this one's actually gonna be none. You can ask Bruce, but this is not linear. It's not quadratic. And it's not exponential. So you need to ask her about this one. Okay. B question mark. And why is she giving you a spring review material for 2022-23?
I don't know.
That's freaking ridiculous. Yeah, we know that.
You want some mango very soon?
No.
Sure.
Yes.
Just leave it there. We'll eat it tomorrow morning.
No.
Let me know when you're ready. Number 1. So the first one. So the reason why I can figure this out is it's not linear because we find the difference. You see it's 6, -2, 5, not consistent, right? Since the difference is not consistent, it's not a linear function. When you check for quadratic, you check for a second difference that is consistent. Do you see that? Remember when we talked about this? Quadratic is a 2 different type of pattern. First one is inconsistent, but the second one is consistent, right?
Mhm.
And a lot of time, the first one, we did this before, is like odd numbers. And you add 3, add 5, add 7, add 9, add 11, right? That's your first pattern. Do you see how between 3, 5, 7, 9, 11, those are inconsistent? But then take a look between 3 to 5. Do you see the plausive 2? Between 5 to 7, you add 2. Between 7 and 9, you add 2. This is the second pattern. This is the consistent or constant second pattern. Do you see that?
Mm.
Do you remember this kind of?
I don't.
Kind of? Okay. Well, go back to the video, okay? Exponential is like when you have 1, 2, 2, 8, 3, 2, 16, 4, 64. Do you see that? How it's just going up exponentially, okay? So, since it's not exponential and not quadratic, remember, given the points do not fit the near linear, quadratic, or exponential, right? This set of points may represent a more complicated relationship, like a piecewise function, and in which case, it's not a function. So what I will say is this one is not a function because it's not linear, quadratic, or exponential. Does that make sense? And make sure you understand that part right there. Okay, take a look at C. Look at the difference. How are you getting from 2, -3 to 2? You could do a 2 minus -3 which is a 5, correct? Right? 10 minus 2 is what? 8. 21 minus 10 is 11, correct? You subtract it there, like negative 2 to 2. 2 minus negative 2 is 4. The what?
5.
That's fine too. Or if you can't figure that out, you can just subtract the 2. Same thing, like negative 2 plus 4 is 2, correct? You can also do 2 minus 2, negative 2, which is still 4. Do you see this is exactly the same? Okay. Did you get 5, 8, and 11? Well, then you're obviously adding incorrectly. So maybe you should subtract them. Negative 3 plus 5 give me 2. 2 plus 8 gives me 10. 10 plus 11 gives me 21. So unless you're not doing it correctly, that's the reason why you don't have it. That's why I'm asking you to subtract. Quite frankly, it doesn't matter if you subtract or add, as long as you do it correctly. If you can't do it correctly, that's a problem.
Okay.
The first pattern is inconsistent. Do you see that? Look at the second pattern. How are you getting from 5 to 8? Is this consistent? Is it linear, exponential, or quadratic?
Linear.
Linear is if you're adding or minusing a number, and it's consistent. Which one has 2 different type of patterns?
Quadratic.
Explain why. Because? Explain why. Determine which of the following represents a function. Okay. A function, remember, write it down. Domain, which is the x value, does not what? Yeah. That's the first thing. Second thing, passes the vertical line test, right? So let's take a look over here. Does the x value here repeat?
No.
X doesn't repeat. So if it doesn't repeat, therefore it's a function. So yes, function. Take a look over here on this x value. Does the x repeat?
Yes.
Where does it repeat?
At 4.
Good. So then how do you explain it?
Function.
And 4 is what? Is 4 y? Make sure you put the x value does not repeat or repeat. So it's not a function. Do the same thing with C. Big bang wheel, the cheese.
It's mozzarella cheese. It's actually like a lot healthier than cheese. So weird. What if it repeats in the y value? Will that still not be a function?
No, y value doesn't matter. If the y value is repeated, it doesn't matter. Just the x value.
I mean, if they're simply dumb.
So far, we determine functions on a chart, right? So this is a chart. We determine how to find the function on a table, right? Now I'm going to do it on a graph, okay, with a vertical line test. Remember how you're supposed to draw a line? How the vertical line test is you draw a vertical line multiple times on the graph. Remember, it can only touch once, correct? If it touches more than once, then it's repeating. X is repeating. So I draw this first line. How many times is it touching?
One.
Good, so it's a function. I draw another line. How many times is it repeating?
One.
Yeah, just once, right? It's a function. If I draw another line, how many times is it touching the graph?
One.
So it's a function. It's a function because graph passes what?
Vertical
Vertical what?
line.
Test. Okay? Now you try that with the next two. See if it passes the vertical line. Okay, if I draw a line here, how many times does it touch? Twice, right? Draw another one. Twice. Yes? So this is not a function because, explain it.
Because it does not pass a vertical test.
It does not prevent the vertical line test because the vertical line touches a graph twice at two and X repeats, right? Determine the domain and range of the functions. Domains are x's, ranges are y value. Domain goes from left, right. Range goes down, up. Yes? Okay. This is a table, correct? To find the domain and range is really easy. Domain is x, right? Range is the y, correct? So you just put domain and list it. Domain equals what? One, two, three, four, correct?
Oh.
Domain is x. Range, y, 3, 9, 7, 12. Is this a function?
Yes.
Why?
Those none of the numbers repeat.
That's a horrible explanation. None of the numbers repeat. Which number?
None of the numbers in the X value repeat.
Okay, B is a graph. When you're looking for the domain, which is x, how far does it go to the left? Where does it start on the left side? And it's a 1, 2, 3, 4. Do you see how this starts on -4? And then does it continue? How far does it go to the right? Forever, correct? So it goes from -4, make sure you put a bracket, all the way to positive infinity. Or another way of writing this is x. X is greater or equal to -4. Do you see that? Bracket. Now let's take a look at the range. What is your range? How far down does it go? How far up does it go? This implies it's gonna keep going down. Yes, forever and ever. This arrow implies it's gonna keep going up forever and ever. So it's negative infinity to positive infinity. What's another way of writing this? All real number. Two different ways of representing domain, two different ways of representing range. You need to review this video. Do you understand? You're not remembering this.
Okay.
You try to find the domain range for the next one. For what?
For the
A, B, or C? The domain or the range? The domain, because how far does that graph go over to the left? Oh, I don't know. Is there an arrow? Is there no arrow? Is it a point? I don't know what the hell. Okay, if there was an arrow, it would be that. Okay, with an arrow.
well, I thought it started like a
Now, if it's a point, what is that? Negative 10. You could say x is negative 10, positive 10. Correct? So negative 10, comma positive 10.
that's what
Oh, that's fine. That's fine.
there's no point or arrow.
I don't know. That's fine. Yeah, that's fine. Okay. Number 6 or 4. The way you read this is f of 6. So what this is saying, I want to pay attention. When x equals 6, f of 6 is y. What is y equal to? When x is 6, look for x and look for 6. Do you see when x is 6?
Yeah.
Okay, where is it? Point to it. When x is 6 is right here, correct? What's your y value? There you go. So f of 6 equals 7. That's your answer. I'm going to try to give you another one. What is f of 0?
1,
What is f of 4?
5,
Okay. If f of 6 equals 3, what is x? If f of x, which is y, is 3, what is x? When y is 3, there you go. Okay. All right, number 5, do the same thing. Wait, hold on a second. Did we miss something here? Oh, yeah, we did. This part that is on the completely different page. You need this part for the last part. So whoever edited this, kind of an idiot. Did a terrible job. Okay. So f of 2, right? f of -2 equals, when it's f of x, you see the function is 2x squared minus 3. If you replace x with a -2, that means anytime you see an x here, you replace it with a -2. So 2 times -2 squared minus 3. Now solve that, or simplify it, please. Next was f of 4. So in this equation, whenever you see an x, you replace it with a 4. Now go ahead and do that. -2 times -2 is a positive 4. Go ahead and do that. 4 squared. B. F of -2. 2 plus -2 squared over 3 times -2 minus 1. Copy this down. F of 4. 2 plus 4 squared. 3 times 4 minus 1. It's your first answer. Okay, let's take a look at the last one, C. C is challenging because it's a trinomial, right? So if you're finding f of -2, wherever there's an x, you do 3 times -2 squared minus 4 times -2 plus 1. So that's 3 times 4 plus 8 plus 1, which is going to give you a 21. Don't copy it down, try it on your own. F of 4, just pay attention for now. F of 4 is 3 times 4 squared minus 4 times 4 plus 1. 4 squared is 3 times 16. -4 times 4, you gotta be careful. You see how the double negative right here, which is a positive. This is a single negative, which is a -16. Do you see that? Do you see the difference here? Because last time when you did this with the test, you made a lot of mistakes with that one. 3 times 16 is 48 minus 16 plus 1. 32 plus 1 is 33. Now you try it. And that concludes the first page of your study guide.